Welcome back guys with a brand new video, and in this video we will discuss about the inductors and transformers, that is the third passive electronic passive components in our list. So let's start. So if we first discussed about the inductor, so we need to discuss about the law of inductions. So according to the law of inductions, when an electrical current flows through a coiled wire, an electromotive force will be generated in such a way that it opposes the flow of current. That is called the law of induction. Here you can see an inductor also. Let me zoom, and here you can check out. This is the inductor's symbols for the different insulators or cores. You can say this is for the air core, this is for the iron core, this is for the ferrite core, and this is for the variable core. So as we discussed in the definition of law of inductions, you can see here, when the electrical current flows through a coiled, this is a coiled wires, then an electromotive motive force is generated that opposes the flow of current in opposite directions. So that is the law of induction. In this picture you can check out what things, or you can say the parts we necessarily required during this. The first one is the length. Second is the inner core materials which we are using. Here we have discussed the four types, and then the cross-sectional area of this core, and the number of turns we wound on that core, and the, you can say, the voltage difference and the current flowing through the wire. So the values specified in henries, that is the unit of inductors, and in millihenries and microhenries. Inductance, you can say, is the property of inductors by which it opposes any change in the flow of current. So a coil of wire that may be wound on a core of air or other non-magnetic materials, or on a magnetic core such as iron, powder, or ferrite, and two coils magnetically coupled form a transformer. So here we have the types of inductors, that is using the ferrite core, and that is using the air core inductors, and that is iron core inductor. So as we discussed that transformer is basically the sum up of two inductors, then you can see here we have the primary and secondary circuits, and that are connected using a laminated iron core. And here we will say that the number of turns for the primary circuitry is uh, mentioned using the NP turns, and for the secondary using the NS turns. The voltages across the primary circuits will be represented using the VP primary voltages, and the current using the IP primary current. And similarly for the secondary circuits, we will represent it using the IS and VS. So we need to understand that what is a transformer. So a transformer is a static piece of any apparatus by means of which an electrical power is transferred from one alternating current circuit to another electrical circuit. There is no electrical, give me a moment please, sorry. There is no electrical contact between them. The desired change in voltages or current without any change in frequency and power, because if the voltages will increase, the current will decrease, and if the current will increase, the voltages will decrease, and the power remains same in the both cases. The transformer works on the principle of mutual inductions. Here you can also look at how the first transformers was built by Otto Blatty, Mixer Derry, and Karoli Zipmo Sky in Budapest in 1885. Sorry. So it is displayed at the Duchess Museum, Munich, Germany. So you can look at the first transformer uh, that is developed in 1885. So here we have different types of transformers, that is step down transformer and step up transformer. So first we will discuss about the step down transformer. A step down transformers is the ones whose secondary windings are fewer than the primary windings. In other words, you can say the transformer's secondary voltage is less than the primary voltages, and because as you know the voltages depend upon the number of windings, so that's why the that is known as step down transformer. So the transformer is designed to convert high voltages to low current power into a low voltage high current power, and it is mainly used in domestic consumption. And if we talk next about the step up transformers, then you can see here a step up transformer is the direct opposite of a step down transformer. There are many turns on the secondary winding than in the primary winding, and in the step-up transformers, thus the voltage supplied in the secondary transformer is greater than the one supplied across the primary winding. Because of the principle of conservation of energy, the transformer converts low voltage high current to the high voltage low current. In other words, the voltage has been stepped up. So if we here we can check intermediate frequency transformer. Intermediate frequency IF transformers work at the frequency of 455 kilohertz and cased with aluminum can. Tuning is achieved by using parallel capacitors across primary and secondary windings, and its applications are radio receivers. And then we will discuss about the audio frequency transformer. Audio frequency transformers work at frequencies between about 20 Hz to 20 kHz and are used in audio amplifier circuits. They are essential involve tube designs for matching the high impedance outputs of these amplifiers to low impedance loudspeakers, but transistors amplifiers have much less need for output transformers. So here we have another topic of relays contractors. So we need to discuss about the relay, that it's here we have a high power source and a low power source, and here we have the load. The relay will only work to switch the to switch it to the high power source and to turn on the load. So here we have its contractors and three-phase AC power. Here we have the 120 volt AC coil, and here we have the motor. So the relays are controlled using this 120 volt AC coil, and allows the three-phase AC power to turn on and off. When a relay is used to switch a large amount of electrical power through its contacts, it is designed by a special name contractors. And this is our last topic of electronic passive components. So thank you so much for the whole series of electronic passive component. If you learn anything new, then please subscribe the channel for more new videos, and hit the like buttons and share with your class fellows and friends. And if you require any type of assistance in your electrical electronics projects regarding the tutoring and assignments and other hardware designing sorry prototyping, then you can please ping me a message on my WhatsApp number that is given in the descriptions, and also you can visit my Upwork and Fiverr profile. Thank you so much for watching the video.